Question 2b is another composition of functions we want to put into function g. Function f evaluated at a minus 3. And there is a parenthesis that's missing here in the problem. There should be another parenthesis here, but that kind of wipes that out. So I'm just going to rewrite it so that it's in there correctly. It's g at f at a minus 3. So we want to put into function f the value of a minus 3. We want to take that output and put it as an input into function g. So I need to put something into g. That something I'm going to put into g is what f at an a minus 3 is. So first thing I'm going to do is I'm going to calculate f at a minus 3. Okay, now function f requires me to take your input and square it and then multiply it times 6. So this becomes the a minus 3 squared plus 6 times a minus 3, then plus 8. So now I'm calculating what f at a minus 3 is. So I saw a lot of people make mistakes when we square this binomial. Remember, when we square a binomial, we get a trinomial. If you're having trouble with that, put an a minus 3 times another a minus 3 and do your FOIL. But I like to square the first one, which is a squared, double the outside inside, so that's negative 3a doubles a negative 6a. Now square the last, which is plus 9. Distribute your 6 plus 6a. Distribute your 6 minus 18 plus 8. So I'm going to simplify what I can. That's a squared. The minus 6a and plus 6a cancel. And then we got to collect our like terms, and a 9 and an 18 is 17. Subtract 18 is minus 1. So we just found out what f at a minus 3 is. This output becomes the input into function g, so a squared minus 1. So a squared minus 1 has to go into function g. Well, g requires us to take a negative 4 times your input, add 5. So now I'm going to find out what g at a minus 1 is. So this equals negative 4 times your a squared minus 1. Remember, this is going in as your input for x, plus 5. Distribute your distribute your negative 4 a squared plus 4 plus 5. Collect your like terms, and we got a negative 4a squared plus 9. This is what our composition of f at a minus 3 put into function g ends up giving us.